Okay, in this next example, we're asked to factor x squared plus 10x minus 20. So again, we're going to be looking now for things that multiply to be negative 20 and then add together to be 10. So we begin to look at the factors of negative 20. We have negative 1 and 20. Those add to be 19. Not going to work. And negative 2 and 10. Those add together to be 8. That's not going to work. 3 doesn't work. That brings us to 4. 4 times 5. One of the benefits and one of the reasons for listing the factors down like I'm doing here is notice that the numbers on this side here are, if you ignore the negative signs, are getting bigger. The numbers on this side are getting smaller. So anything left that could go into 20, now 20 is not a hard one to figure out, but if it's a bigger number, this way we make sure we don't miss any factors. The only thing left now must be between 4 and 5. Well, there's no integer between 4 and 5. And so we know that we've gotten them all. None of those add to be 10. When this happens, and again we did negative 1 and 20, that adds to be 19. 1 and negative 20 would be negative 19. The sign would just change. So we got 19, 8, and 1. None of those are close to 10. None of those are 10. So when this happens that none of the factors work, we declare that the polynomial is prime, which means it can't be factored. So every once in a while you'll run into a polynomial like this where you can't factor it. Okay, and that would be the result. You would say, it's prime, I can't do anything with it. So let's move on now to example 2 here. As we look at example 2, it looks a little different. You say, well, wait, we were talking about polynomials that didn't have anything in front of the squared term. Well, ultimately that is what we're talking about. But this problem here, if we look at it, we inspect it a little bit, we say, well, wait a minute, we can do something else with this that we couldn't do with the other examples. Remember in the first section in this chapter, we talked about factoring out a common factor. And so if you look through here at the 3, the 15, and the 18, you say, well, hey, I can pull a 3 out of each of those. And if you can ever do the factoring the GCF, please do that first. It will make things easier. And so by pulling out that 3, we're now left with x squared minus 5x minus 6. And now we do have a polynomial that fits the format that we're looking for. So we can now say, hey, we need things that multiply to be negative 6, add to be negative 5. Again, pause the video, take a moment, try to figure out those ones. Be careful here. They have to multiply to be negative 6. That means one's positive and one's negative. So welcome back. Hopefully now you've found the pair that works. Things that multiply to be negative 6. So the 3 just tags along. Would be a negative 6 and a positive 1. And again, whether you write that as x plus 1 first, then x minus 6, or as I've written it, it doesn't make a difference. Okay, and so now we have our result. Okay, so now we're going to move on to our third example. So as we look at example 3 here, we say, well, this looks like it's a lot more complicated. I ask you to take a moment and try the problem. Just erase those y's out of the problem and just try to factor it and see what you can come up with. The fact that the y's are in there does make it seem a little more difficult, but the y's are actually behaving, if you think about it, kind of the same way the x's do, except on the other side. And for that reason, because we have the y in the middle and a y squared on the end, we can actually forget about the y's for a moment and just answer the question. What multiplies to be 12 and adds to be 8? Alright, and we say, well, hey, a 2 and 6 does that. And so we can then write our answer down, x plus 2, and because of the y being in the middle and on the end, we attack attach the y to that 2. And the same thing, x plus 6y. We just attach the y onto the end. When we see the y's in the middle like that, we just attach them onto the end and factor it just like we normally would. We don't do anything special other than that. And so if you're having a little trouble with that idea, pause the video for a moment and multiply those out. Multiply our answer out and see that, yes, that does in fact give us the result that we want. Okay, so this is just a little bit more with factoring these kind of polynomials. Hopefully this helps you out as you start to get into some of the homework problems.